All right, so we started this unit before we took the tests about trying to show that two triangles are congruent. And we said that the only way to do it by definition was to prove all of the matching sides were congruent and all the matching angles were congruent. We called them the corresponding sides and the corresponding angles. But that was 6 things. So, of course, mathematicians looked at that and went, I can do that in 3. Hold my beer. Just kidding about the hold my beer part. Although some of the mathematicians, that's probably true. But they figured out that there were shortcuts to doing this. Okay? For example, here's the first one. This is called the side-side-side congruence postulate, which is a lot of words. We usually just say side-side-side, and we abbreviate it SSS.
You say
No. There will be no hissing. So, oh my goodness. If 3 sides of one triangle are congruent to 3 sides of another triangle, those 2 triangles are congruent. In other words, if you build 2 triangles out of the same 3 side lengths, the angles will take care of themselves. The matching angles are going to be the same size. So in this diagram, triangle RST is congruent to triangle LKJ. Remember that the order also tells you what goes with what. That tells you that segment RS goes with segment LK. And if we look at this, segment RS is 5, segment LK is also 5. So the order is important when you write those. So that's by side, side, side. And if you think about it, if I gave you, I don't know, 3 pieces of uncooked spaghetti of 3 different lengths and said, put them together to make a triangle, end to end, well, there's only one way to make that triangle, right? I mean, you could flip it over and turn it and all those kinds of things, but it's still going to be exactly the same shape. So that is the side, side, side congruence postulate. Again, we'll just call it side, side, side. And we'll abbreviate it SSS because, well, we're mathematicians, which means we're really efficient or really lazy. So here, this is like one that is on your homework tonight. It says use side, side, side to explain why triangle SAN is congruent to triangle SAT. So when they say explain, they mean write it out. So, no, I'm not going to do that. I'm going to use my pen so that you don't go, you get to type. So here, we're given that, what 2 things do we know are true?
SN is congruent to ST.
Yeah, segment SN is congruent to segment ST, and
Segment NA AT.
yeah, segment NA is congruent to segment AT. That's all given information. Is that enough?
No.
Well, I've only got 2 pairs of congruent sides. That would be side, side. I need to have all 3 pairs of sides congruent. Well, what's the last side for both of these triangles?
SA.
SA. And we talked about this the other day when we were doing things. How do I know that SA is congruent to segment SA?
The reflexive property.
Yeah, the reflexive property. Segment SA is congruent to segment SA by the reflexive property. Again, that's like a reflex action. Same root word. By the way we mark that on the diagram is just to put an X across it. And the reason we do that, I have students who sometimes go, well, why don't you mark it with 3 marks? Because that would be the next one. Why is that a bad idea? Yeah, because nothing else has 3 marks on it. That's exactly right. That's why that's a bad idea.
What if we did 6 marks?
Well, nothing else will have 6 marks on it.
No, like 3 marks and then the 3 marks.
That's like saying the one with 2 marks has 1 and 1.
So we mark it with an X like that. I also like this one because it reminds me that it's the reflexive property, because occasionally I have students who write the reflective property, which is a different word. And they're like, you're going to count off for that? And I'm like, yes, you have done a different word. I don't really care all that much about spelling unless it's so bad that you've actually spelled a different word. Okay? Actually, I care a lot about spelling. I just don't take off for it. Because I know when I was your age, I was not good at spelling. I didn't come be good at spelling until much later. All right. So, triangle SAN is congruent to triangle SAT. By side, side, side. All right. Here is the second congruence postulate. This is the side angle side congruence postulate. It's a little more involved. It says if 2 sides and the included angle. So when you see the included angle, think about the angle that's formed by those 2 sides. Of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So here in this diagram, I've got these 2 sides, FA and AS, are congruent to TI and MI respectively. And then angle A, which is the angle formed by those 2 sides, is congruent to angle I. The angle formed by these 2 sides are congruent. That's side angle side. And the reason we write side angle side and not side side angle, for example, is that where is this angle relative to the 2 sides?
In the middle.
It's in the middle. It's in between them. Right?
And we all know why we don't spell it the other way.
Pardon?
Sebastian.
Oh my gosh.
We'll actually talk about that later on.
Oh,
It-
wait, what?
It turns out that there is no such thing as the ASS theorem. It doesn't work.
Oh, that makes sense.
Yeah.
And I usually say, if you don't want to be one, don't use it. All right? So here, let's use side angle side to explain why triangle RAT is congruent to triangle BAG, given that A is the midpoint, and I'm sorry I forgot to write this, of segment RB and segment GT. So when you're writing this out, you always start with, what am I given? We're given that A is the midpoint of segment RB and segment GT. So, what do we know? If A is the midpoint of segment RB, what conclusion can we make? Yeah. So segment AR is congruent to segment AB, and
Segment AT is congruent to segment AG.
Yes. Segment AT is congruent to segment AG. Well, I've got two sides. That's not enough for side angle side. And I've used up what's in the given, but I was also given a diagram. What is it that we see in the diagram is true?
That angle RAT is congruent to angle BAG.
Because,
Because they're vertical angles.
yeah, they're vertical angles, and what do we know about vertical angles?
They're congruent.
They're congruent. So, angle RAT is congruent to angle BAG because vertical angles are congruent. And you're absolutely welcome to abbreviate and use symbols when you're writing these out, because it can get pretty long if you don't.
Isn't this just a proof?
Yes, this is a paragraph proof. It's just like a proof, but you're writing it out in words. Therefore, triangle RAT is congruent to triangle BAG by side angle side. Oh, I should teach you guys a symbol. Do you guys know the symbol for therefore?
No.
Arrow.
No?
No.
3 dots in a little triangle pattern like that is the symbol for therefore. You're welcome to use that. Anyone who knows, math at any kind of an advanced level will instantly recognize that. There's a whole bunch of them. I don't use all of them, but this is one I use all the time because, well, therefore has a lot of letters in it. All right. So here's another kind of problem that we're going to do. Show that the triangles are congruent for the given value of the variable. All right, so that means we're telling you they're going to be congruent. How do we know that? Well, here's how I would start it. I would say QR is equal to 5, right? Because QR has a length of x and x is 5. So, segment QR is congruent to segment NO. And I just work my way around. The length of RP, is equal to 3 times 5 minus 9, which is 6. So segment RP is congruent to segment OM. And then QP has a length of 5 plus 2, which is 7. So QP is congruent to segment NM. Therefore, triangle, when you name the triangles, you can name the first one any way you want. The order is not important. I'm going to call it NOM. But when you name the second one, you've got to make the corresponding parts match up. Nom, 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 nom. Figured that was appropriate for someone who had eaten so much for lunch.
Yes. Mr. Davis.
By your own admission.
Yeah, I can say it. You can.
Okay.
So QRP? Triangle QRP?
Yep, QRP.
What
And
is
I know that because NO matches up with QR. So these are like holding your hands up like this. They're mirror images of each other. They're not like this where you have to slide one over. You have to be really careful about that. Sometimes they'll be mirror images of each other. Sometimes they'll be just slid over. It just depends. And how do I know this? By side, side, side. Because I've proved that all three pairs of sides are congruent. We can also do ones that involve angles. So for this one, the measure of angle T is going to be 20 times 4 plus 12. And you're like, do I have to write that? Yeah, that's part of showing what it is that you're doing, which is equal to 92. So angle T is congruent to angle W. The length of segment UT is 4 plus 3, which is 7. So segment UT is congruent to segment XW. And the length of ST is 4 squared minus 5 is 11. So segment TS is congruent to segment WV. Therefore, triangle, and again, the first one, name it however you want. Abby, how do you want to name this one?
SUT.
Okay. So we have to name the second one so the corresponding parts match up. So I know, well, I know that T matches up with what? W. So I know W has to be the last letter. Let's see, the last two here were UT. What does UT go with? XW. So the T and the W matched up, so X has to be here and V has to be here. By side, angle, side. Got two pairs of congruent sides, and the angles in between them are congruent to each other. All right, so let's do a proof with these. We've already basically, as Lexi so correctly pointed out, we were doing proofs earlier. All right, those are just paragraph proofs. So let's do it 2-column. If you want to do it as a flowchart proof, you're welcome to do that. Because, well, I like to amuse myself. These almost always spell something. So in this case, the slightly wishful thinking for this time of year, snow. So we'll start, your book typically splits up the given. I just write it all at once.
Yeah, it confused me for a sec last time we did the homework.
Oh, where like question, number 4 was given.
Yeah.
You're like, wait a minute. Yeah. What they're doing is they're saying, I'm going to take this piece of information, what can I get from it? And then I'm going to take the next piece of given information, what can I get from it? That's what they're doing. So I've got SN is congruent to OW, and SN is also parallel to OW. Well, if I've got parallel lines, all that stuff is still in play. We're still in geometry. We don't forget things from earlier. So if these two lines are parallel, what conclusion can I make that would be helpful about proving these triangles congruent? Wait a minute, I'm sorry, say it again. Yes, because what kind of angles are those? Alternate interior angles, exactly right. Angle NSO is congruent to angle WOS by the alternate interior angles theorem. That's still not enough, and I have used up the given. But the other thing you're given is a diagram. What is it in the diagram that we can see, that we can say, oh, I know this is congruent to that?
Segment SO is congruent to segment SO.
Yes. Segment SO is congruent to segment SO. And what's the name of that? Yeah, that's the reflexive property. Almost all of the proofs that we're going to do in this unit either have the two triangles share a segment, or later on we'll get to some that share an angle. That gets a little bit weird, but they overlap each other. Or they've got vertical angles. They've got almost always one of those three things pops up. Not always, but almost always. So, well, now I have enough to prove the triangle's congruent. Triangle SNO is congruent to triangle OWS. And what's my reason for knowing those triangles are congruent? Side angle side. I've had enough of your sass. Any questions about that? All right, your assignment is in the book.